Yes, so in a last class we had seen the pipe. Do you have any doubt in pipe?
No, sir. Actually, I did not work on it. Actually, yesterday was a lot of meetings was there, so I did not have time to read that. But today I will read and I will check if any doubt.
Please do it, okay?
Yes.
Because like we will not move further like if you not do.
Yeah.
Okay. So now we are doing FIFO. What is FIFO? FIFO is first in, first out. Like that pipe is having some problem. Like, do you see any problem in the pipe?
No, sir. I did not find out.
Yeah. So you do practice. When you do practice and come, you will have understanding. See, the pipe is having the one problem. Like it can only communicate with the relative process. Like we can only transfer to the parent to the child and child to the parent. Only this much we can do. So due to that, what is happening is due to this parent and child only, what is the problem is like if some process which is like not relevant, we not able to communicate. So consider like some process which you made separately and you want to send data, you will not able to do. So for that purpose, we are having solution is named pipe. So this FIFO is a named pipe. FIFO is a pipe that has a name. So FIFO is also called as named pipe. FIFO is designed to let them get around the one of the shortcoming of normal pipe. So normal pipe is having few shortcomings, few problem, and one of them is that like it not able to communicate with the non-related processes. So the FIFO is able to solve that problem.
Okay.
So it is something like that. So when we are having user process 1, process 2, so like when the process 1, process 2 are there and if they want to communicate, so for that purpose we create one file and this file will say like it's a basically it's a FIFO file. So through that file we will able to read and write. It's like that. And this file is controlled by the kernel. Means it's inside the kernel actually. This file.
Okay.
Yeah.
Sir, we can we can do like if example 2 files are there.
Sorry.
2 processes are there. We can write with 2 processes, sir. Like write command we can give for both the process using file.
Yeah, we can give, yes.
Okay.
I not understand your question.
Usually that one side is writing and another side is reading.
Okay.
We are using 2 processes right now.
No, that will be still there. That problem is not, means that still we have to do the write and read. That will be there.
Okay. Okay.
I understand what you are saying.
Yeah.
So the how once you do experiment, you will understand, and then we can discuss this. You won't ask this question once you show, means you see like how I am doing. FIFO creation. So how we create the FIFO? FIFO can be created similar as we are creating the file. How to create FIFO, I will tell you. And the creation with a special parameter and permission. So we have to create the FIFO, and how to create I will tell you in 2 minutes. And once you create, then like it will be same as the file. And after creating FIFO, we can do read and write. Can be performed like how we are doing earlier, like read and write in our previous assignment or in our previous training you had done the read and write. So if not, we are doing now. So finally a device number is passed, and this ignored when the creating the FIFO, and which you can put anything you want there. Subsequently FIFO can be closed. Okay, so what we are saying, while we creating the FIFO, it will ask for device number or something, that we can write anything there because we are not using that. And subsequently after like using FIFO can be closed. So probably like you may not grasp it what I am saying, but it's okay. Once we see, then you will able to understand. So let's start writing FIFO, and let's see what all system call it required to do. So first one system called is MK node. So what is this MK node is? What is
Creating for a file, device file.
Sorry, what you say?
Creating for a device file.
Yeah, but like here we are using, if you go in a manual page of MK node, it's having some option we can use for the FIFO also. Yes, it create the device file, but we can use this for some other purpose as well. So see MK node, this is not this one. Okay, so see the file type. So the file type must be
Yes.
You see the MK node create a file, device special file, and or the named pipe. So we are interested in this named pipe. Other two we'll discuss later.
Yes.
But we are more interested in named pipe. So when we are creating the name pipe, then we have to give the mode, means which mode we are creating.
Okay, sir.
And we have to use this s underscore I FIFO for flag here. Okay.
Yes.
So we have to make MK node. In MK node, what all we have to give? Like MK node, we have to give the name and the mode and the device. So here we can write anything actually. Anything in the sense, this parameter is used when we are creating only the device file. So currently we are not creating the device file. So but like mode we have to give. So mode will come this one, s underscore I FIFO. Name will be name. That I'll show in 2 minutes.
Yeah.
Then MK node return 0 on success and -1 if error occurred. MK node return 0 on success and -1 on error occurred.
Okay.
That's all. So now I'll do it. That's all. MK node I showed. Let's move to here. So now we have to use the MK node. MK node containing this 3 thing path, where like FIFO need to create. Where we have to create the FIFO, whichever folder or something, we have to give the name. And then we have to give the mode. Mode is the permission, which is same as like normally when we are opening the file, like we are giving some permission, read, write, an execution.
Sir, that 066 is there, no, sir? What is that meaning, sir?
This is the permission. 0666, if you convert into binary, it will come basically 011. 6 if you convert, can you convert 6 into binary?
In 8, 0110.
0, so leave the initial 0.
Yeah, 110.
110. So this 110 says like we are having 3 type of permission: read, write, and execute. So we are giving permission for reading and writing.
Okay, sir.
And this 3 means like one is user, one is group, and one is admin.
Okay. User, group, and admin.
So now after creating the FIFO file, once we create the FIFO file, it will give the file descriptor. And once we are having file descriptor, using that file descriptor, we have to open that file. How to open? This normal open file name we are having means open system call. We will open the file, and after opening we can write it, and then we can close it. Same way in the next time, same file name we no need to create again, but like we have to open it, and then we have to read it and close it. It's like that. So in one process we can read it, in another process we can write it. But in another file also we have to do mknode with the same file name. When we do mknode with the same file name, it will not create. It will be open the existing file.
Okay.
I'll tell you a little bit. Say from one process, if we created if one process we had created the one file, and from another process, once we give the same name, consider his name is H, and from here also if we try to open H, it will not open new, it will open same file, and it will give the file descriptor. Then we can open the file here and read it and write it and then close it.
Sir, one more time, sir.
Let's see the example. Once you see the example, you will understand faster. So now here it is. What I did, like I created some variable, init variable, and what I am doing, mknode. Why init variable? Let's see what mknode is returning. So this mknode is return integer. Mknode return integer. Got right what I said?
Yes, sir.
So mknode return integer. So what we did, we are checking here like mknode, and then we given our FIFO name, what FIFO we want, whatever name you want, because whatever we have to, even if we have to read or write, we will read write with this name. And then we given the permission here 666 means read, write, and execute. And we are saying create the FIFO. So this 2 parameter we have to give. This is the device file. This parameter is for device file, but that device file we are not creating. That we may create in a Linux device driver course. So now, okay. So this is done. Now what we did is, now we have to open. So we'll open file. We already have the file. We are already having file. We'll open the file and in the read only mode. So we are opening the file in the read only mode, and once our file is open, with that it will give the file descriptor. So let's see the open system call here. So did you use open system call earlier?
file in file, sir.
Yeah, file operation, open, close.
Yeah, earlier was
Okay. So in the open system call, we have to give the path name and the flex and integer. It will return integer. Okay. So if you read it here, then see the flag must be include following. Like flag must be include read only, write only, read write. This flag it must include. That is what the 6.6.
Okay.
So this is what it. And then apart from that also if we are having some other flag, and the meaning is mentioned here. See, you can see here, like say 4. 4 means user had read permission. Okay, and then user has write permission. These two. So if you combine these two, it will become 6. If you combine these two, what will happen?
600.
Yeah, it will become 600. So it means like this is the user permission. Then we are having same thing for group and same thing for other.
Okay.
That's why like it's 666 coming. But if you don't want to give 666, then you have to give the specific condition, specific tag here.
Okay.
And then the return value. Return a new file descriptor or -1 error occurred. Okay, so this function will return the new file descriptor. And if you see on top, this open system call is returning integer. So it means that open return file descriptor, which is like integer type basically. Did you got what I said till now?
Yes, sir.
Okay. So now how to open? If you want to open the file, let's give the file name and in which mode we want.
Yes, sir.
So FIFO is already created. Then we opened the file in a write only mode. So after that we are checking whether like if it is a -1 or other than that. So if it is -1, it means error. If not, it means like all good. Go ahead.
Okay.
Now here like we are having we are doing the write operation. So for that we are having file descriptor, which we just now got it. And once we are having file descriptor, then what to write. So this is my variable and what is the size. So this is one integer variable. So I am writing the integer variable and that's all. Now we'll see this like how it is working. And same way at the other end we need to have once we are having the FIFO, once FIFO is opened and once we write, this write system call is a blocked call. Blocked call means like process will stop here, it won't go further.
Okay.
Because like this pipe is not like it not storing the data, it is like just passing the data. So we need to open this file in some other place for the reading purpose immediately.
Okay.
Did you got what I said?
No, sir, properly.
Okay, I'll tell you 1 second. So when I come to program, I'll tell you. Before that, I will show you. So like I'll demonstrate and then I'll show you other things. So consider So mk node, file name, and then P. So P is for the FIFO. If we see here, like it came my FIFO.
Permission is not required, sir.
It should require. We'll see like how it.
Okay.
So it's saving. See, like it's saving the read write permission, and then so it's saving read write and read write. So probably like we'll able to read write. Read write permission is there. Root and user both are having. Okay, only group does not have, so it's okay. I think we should able to read and write. Now let's write it. So how to write? We can say cat, and consider we want to write where we want to write my file, and now whatever I write, hello Manohar. See, now this process is blocked. I am fine, but nothing is blocked. See, I open this, but this process is blocked. Why it is blocked? Because the pipe cannot store the data. Once you open the pipe, it need to immediately deliver it. It cannot hold down. So what we do is, here if you see ls, here also we are having the pipe. Then we can start reading the file. You see now?
Okay.
Whatever data we had sent, that data is now delivered. Did you understand what I did? I able to communicate among two non-related process. I am able to communicate it through the command line.
Yes.
Did you got what I said? Or?
Yeah, sir. Yes.
Okay. Now we'll write the program. So we had seen this thing. Now we'll write this program. So we need to have init variable. First we have to do mk node, file name and the permission. So we'll do the first let's say mk node, and then we can say first file name. So we can say same name I'll give, I'll remove or I'll change FIFO1. Then permission, so 0666 board with, and then I want to create the FIFO. So if I want to create the FIFO, I have to do main to so path name I given. Now I am giving mode. So mode I given read and write. Apart from that, I have to give this also.
Yes. Wonderful.
And then the next parameter is for the major and minor number, which I'll write 0. Anyway, when I'm creating this, it will ignore them. So this will return what it return. Its return value is 0 and -1. 0. If we want, we can check that one. On return 0 on success and -1 on failure. So that we can check it here. if we want, we can receive this one here and we can check. Let's say if it's say the B error means print error. Now our node is created. When we come here, it means our node is created. After creating node, what we can do is, our FIFO is created. Then we can open the file. So we have to use open. And for open, what we have to give? First, for open, we have to give the name of file. So FIFO 1. So double quote. So we have to give the name of file, and then we'll see the main open system call. So in open we have to give the path name and the flex. So for open we can say like it may be write only or read only, that we can say, and we can check the return value. So what is the return value of that and what is the flex? So flex we can use this one, flex, and what is the return value of this? Are you getting what I am doing or you not understanding?
Understanding, sir.
Okay, so in open like this also it return either file descriptor or -1. So we can check whether it return -1 or not. If it is not written -1, it means it got success. And this open system call will return the integer. So we have to make one integer variable which is like maybe integer variable that will be maybe file descriptor, and it will be integer type. So we can say like fd, something like that, and then here we have to give the permission, write only. Okay, so that is what we had done it. And then we have to check whether like our program is, means our file is opened or not. So if it is less than 0, it means error came, otherwise we had opened. Once we opened, then we have to just write it. Okay. So now we can check whether like my same check we can put it here also. After this we can check whether my file is open or not. So if my fd is equal to -1, it means we not able to open. So we can say p error.
So P error is same as printf, sir.
Yeah, it will show as a error only, and we can exit from there. With the error code it will show.
Okay.
Before file not open. Now here means file is created. Once file is created, now then what we can do is we can do the writing. So now here what we had did it, we are having one variable, and that variable we are it's an integer variable. We are writing some value, and then we are using write. So in write system call, we have to give the file descriptor and the address of like whatever we have to show, that address, and the how much byte I have to show. So then I can close the file, and that's all. Other thing is nothing. Okay, so this is almost done. Here we need to have the FD, which is this one, and means which file we have to write, and PP is one integer variable, so that I have to make it. That's all I believe. Let's see. For FIFO, we may need to include all this, even for open, so that I not included. Type, weight, and UNISTD. Type, state, and okay. This I have already. I don't have segment. Same way for MK node also we have to check it. State function unit state. So state function type and unit. Yeah, all are there. GCC 4 Okay, so this is created. I'll make one more copy of same file. FIFO.c, and I'll say FIFO. That was for writing, so I'll say R.c. That is for reading. Because until I have the file for reading, it won't be. It will in blocked state. So here also I have to do the same FIFO name I have to use, and then I have to open same here, but not for writing. I have to do the for reading purpose. So I believe and now here I have to read it. So what I'll do is I'll do the read system call. So this read system call is also blocked call. So means like if we fire the read command, and until unless it read the data, it will blocked, and then we can close, and that's before read complete.
Sir, that is read FD comma and ampersand PP is there, na, sir?
That I am checking one time. I am checking the read system call.
Both 2 times is there. That's 2 times it is there. That's why. What is?
No, we are writing 2 times, no?
Okay.
2 data we are writing from there, so I have to read 2 times.
Okay, sir.
Do you know in the write time we are sending 2, na? One time 100, one time 200.
Okay.
So here also we have to read 2 times.
Okay, sir.
So in the read system call, we have to give the file descriptor and the buffer where we want to read and how much we want to read. So in the file descriptor, then the variable where we want to read and how much we want to read. Same way here also. I think should be fine. So that's all. So our now both program is ready. Let's run it. So first I'll say FIFO, and now this is blocked, and if we see by now you see this FIFO is created.
Yes, sir.
Are you getting? This FIFO is created and this is in a blocked call. Now it is blocked. Until unless somebody reading this FIFO, it will stay in a block condition only.
Okay.
So that is what in the earlier I was saying, it is a blocked call. This is the meaning of that. Now here we have to do for the we have to read. Once we start reading same file, then it will be get data and it will both will be finished.
Okay.
So I'll give enter here. Oh, okay. So here like in the read system call, file is already there. So I have to use some different permission, because that how to read it. Since file is already created, so I have to describe that thing. One second, file name, then 666 and S before. We not printed this, so this one thing is missing, so that we have to print it. But it's giving me error. It's saying file not created, file exists. See, file is what we had done is actually we put this check. So since file was already exists, it told it's error. File not created, file already exists, like that. But this is, we know this thing, na? Means if file is already exists, so we don't want that one. So we have to avoid this error. Did you got what I said?
Yes, sir.
The easiest thing is like I can remove this code, and another thing like I can go and I can check in the MK node what code it is coming. So I can say like main to MK node, and I can check in a return value. So on it return -1 if an error occurred which is in the error number. So it is set in error number. So we have to check which file. So path name already exists, this one. Are you getting what I am saying?
Yes, sir.
See this thing in error number we have to check the E exists, and this E exist will be in which file? This E exists in a error. It is error number. So consider here, if A is less than 0 and error number is not equal to E exists. Means if any other error is there, then okay, no problem, but it should not be equal to this. Did you got what I said?
Yes, sir.
Let's build. It will give some error. Okay, so now this is still in same condition, means we already wrote here, but the reading part we have to do now. So my program is compiled. I'll run it now. So see, file reading is complete, but nothing, our data not came. Our data not came. Why? Because we not printed the data. We got the data, but we are not printing it. So we got data here, but we not printed. So after reading, we can print it. Are you getting what I am saying?
Yes, sir. Yes, sir.
So the read is also blocking system call. So this is also blocked until unless we are running. Oh, sorry, because here also we not did the check. That same check we have to put it here also in the writing also. What was that?
Exist. We exist.
So now it is in blocking stage, and I'll read it coming. Same way, if I read it, so this will also block until unless it gets the data.
Okay.
So now this is two non-related process are communicating. So this is very simple. Okay, I'm showing you like how you can do with the, like, by reading the manual. When you are working in any company, you only will able to use the manual. You won't get much data on internet or anywhere. You have to go through manual pages and execute it. Okay, that's all,
Yes.
Manohar ji.
हाँ सर.
Okay, chalo, bye.